if we define L of n to be the product of m choose k and n minus m choose r minus k divided by n choose r, then we want to show that our function L of n increases for n less than mr divided by k. Now, your first instinct here might be to try to take some derivative with respect to n. And that's not a bad instinct, right? But in this case, it's going to be a bit trickier. It is possible to take derivatives of these binomial coefficients, but it's not fun. So I'm going to show you another way to do this. Since we're working in a discrete world, we can do stuff like this, right? Where we look at the ratio of our function with respect to n divided by our function with n minus 1, right? And then just using our definition of the function, I have this product here of these two fractions where I have flipped the fraction on the right so that it's no longer in the denominator of our original ratio. So already you might see kind of where I'm going with this. If this ratio is greater than 1, we know that n is L of n is increasing while n is less than that. If we can show that, obviously, we need to show that. So let's start by simplifying our binomial coefficients. So the first thing I'm going to do is I'm just going to expand them, and that's this mess here. But already, right, you see that there's a lot of stuff we can just right off the bat eliminate, right? So our m factorial divided by k factorial, m choose n minus k factorial, whatever. Just knock that out, right? We have some r minus k factorials. We have some r factorials. We can knock those out. And then you'll also see that we have, n minus 1s that are pretty similar to our n's, right? And in that case, we can just keep the n version, the one that's 1 larger, and remove the factorial entirely, right? So what we end up getting is all on our left-hand side of this fraction, right? We'll have n minus m divided by n minus m minus r plus k, and that whole fraction divided by n divided by n minus r, right? So you just look at the left-hand side and eliminate those guys, the right-hand side and eliminate those guys, and then you'll see this ends up happening on the left-hand side. So if I flip the bottom fraction that I just mentioned, then I have this result here. And now we're in the money now. This is going to be pretty straightforward. So remember what I said, we need to show that this ratio is greater than 1. So to do that, right, I can just move my bottom stuff to the right, like I'm doing here. And then I can expand, like I do here. So we have on the left-hand side, n squared minus m times n minus r times m plus m over mr, greater than n squared, blah, 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 blah. And then you just cut those guys out, right? You add them or subtract them from both sides. And then you're just going to be left with our final equality here, right? Where we just need n less than mr divided by k to prove that L of n is increasing. And then we're done.